So today in section 12.4, we're going to use similar triangles. All right, so the key word here, use. All right, we're going to use the fact that they're similar to solve for unknown side lengths and angles, and we're also going to try to prove similarity by comparing angle measurements. All right, so here's something you need to know. If two triangles are similar, all right, when they're similar, they're different sizes, but all of their sides and angles are the same ratios, or the angles are going to be congruent. The sides will have the same ratio and the angles will be congruent. So that's what we see here. We see, okay, angle A is 65 degrees. What's angle D? 65 degrees. So even though the triangle is bigger, its angle measurement is still the same. Okay? Angle B is 95 degrees. Well, guess what? Angle E is also 95 degrees. Now, I want to stop here for a second. All right, this is really important when it comes to proving similarity. All right, what is the sum of the angle measures of a triangle? What's the sum? It's 180. Will it ever be anything but 180? No. Okay, so I want you to hear me on this. If two of my angles, all right, so we see on both triangles, I have an angle that's 65 and an angle that's 95. If two of my angles are the same, my third angle has to be the same because they have to add up to 180. All right, so these two can't be like 65 and 95 and then 30. No, because it's got to add up to 180, right? So the only measurement the third angle could be is 20. Well, it's not going to be anything different on the other one. You following me? So if two of my angle measures are the same and my sum has to be 180 on both, the third one is going to be the same. All right, so take this other example. If you have one angle that's 100 and one angle that's 50, okay, on two different triangles, what's the third angle going to be? One's 100, one's 50. The other one's going to be 30. Would it be something different on the other triangle? No, because they have to add up to 180. So if you can prove similarity on two sets of angles, the third one is going to be the same. All right? Okay, so how does this apply to, the lesson today? This type of question is going to be on your quiz and your test. Okay? This is the only type of question that ends up getting taken from this section. So, in other words, this is the most important example. Okay? So here we go. It says, tell whether the triangles are similar. So if they're similar, their angle measures will be all the same. Okay? You all right? Everything good? Any questions? Okay. So, all right, let's look. 50 degrees. Does the second triangle have an angle that's 50 degrees? Okay, so there's one pair of angles that are the same. Now we have 75. Does the other triangle have a 75 degree angle? Yes. Yes, okay. So it doesn't matter if we solve for x or y, right? Like we could solve for x. What's 50 plus 75? 125. So what would x need to be in order for the sum to be 180? 55. It has to be 55. Well, guess what? I'm adding the exact same values to solve for y. So what do you think y is going to be? 55. I don't have to write that out. I know that y is also going to be 55. So if x is 55 and y is 55, then they are similar. They're similar. Why? Because all three angles are congruent. Okay? And I proved that. Okay, so let's look at this next one. All right? Again, I'm comparing angles. If I have all the same measurements, then they're similar. So do you see a pair of angles that are the same between the two? You see the two 90-degree angles, right? So I have one pair I've got my 90-degree angles, but look at the second ones, 42 and 38. But look here, guys, that doesn't mean they're not similar, because what if y is 42 when I solve? Or what if x is 38? Then I do have my pairs. So you have to solve for one of them, okay? You don't have to solve them both, because once you solve for one of them, you'll be able to see if they're similar. So let's just everybody solve for x, okay? Let's everyone solve for x. So we have 90 plus 42 plus x equals 180. All right, what's 90 plus 42? 132. Plus x equals 180. Subtract 132. And x has to equal 48. Okay, in order for these three angles to add up to 180, x has to be 48. All right, so I know all three of these angle measurements, 90, 48, and 42. So on the other triangle, I have 90, but do I have a matching 38? No. So this 38-degree angle has no match. Do you see that? There's no angle on this triangle that matches 38, because I just solved for all three of them. So because of that, they're not similar. I don't need to know what y equals. Okay? It's going to be a different number, but it doesn't matter because 38 doesn't have a match, so they're not similar. All right? Is that making sense? Okay. All right, so I just say no. They're not similar. All right, and you can just say they're not. As long as you have work here, you can just say they're not similar, because I know that your work is proof of that. All right, and you see that they don't match up. Well, don't count on the visual, though. You've got to prove it, because it could just be off like very, very slightly. Okay, so now on this next one, I want you to prove similarity. Okay, you do that by either solving for x or y, because the original triangle, yes, I have one pair here, but I don't have a second pair. So I have to see, is y going to be 80 or is x going to be 71? You have to solve for one of them to prove similarity. All right, so go ahead and do that on your own. Okay, so 28 plus 71 gave me 99, plus y equals 180. When I subtract 99, I got 81. Okay, well, that's a bummer. So y is 81. I got my 28, but do I have an angle here? So this 80 right here is looking for a pair. Well, I know this one, and I know this one. Is there any chance of me having an 80-degree angle on that triangle? No. My angle measures are 28, 81, and 71. So there's no pair. There's no second pair. All right? They're not similar. They're not similar. They were almost similar, weren't they? It was only 1 degree off. If y had been 80, then that would have been a pair. But it wasn't. It was 1 degree off. All right, not similar. So can you determine whether JKL and JMN are similar? All right, parallel lines, we're going back to 12.1. So there's a reason why we reviewed that at the beginning of class. Parallel lines. And actually what we have happening here is we have a transversal cutting through that top side. That's a transversal. Is it not?
What is a transversal?
Okay. Transversal is the line that cuts through two parallel lines. Okay. So when that happens, it creates congruent angles. Do you see how those two angles of the triangles, those are corresponding? That's important. Now, look at the bottom side length of the triangle. So now you've got your parallel lines running this way. And the bottom side of the triangle is running this way. So guess what? These correspond too. So because the lines are parallel, I know that K and M are the same, and so are L and N. And they both share angle J. Look what happens with angle J. K, J, L, M, J, N. J is the same angle on both triangles. I can see that all three angles are congruent. So yes, they are similar. Angle J is shared. Both triangles have that angle. And because line KL and MN are parallel, so their angles are congruent. Their angles are equal. You can say equal, you can say congruent, same thing. All right? Now, if those two arrows were not there, I can't prove it. They could be 1 degree off. They could be half a degree off. I wouldn't know. If these two lines were not parallel, there's no way I could determine, here's my key word, determine whether they're similar. All right?
So the parallel ones are similar.
Yeah, parallel lines will create, and then, you have your transversals that are the side of the triangles. So yeah, parallel lines create equal angles. Yes. All right. What about this guy? Hold on. Just see if you can write down your answer. All right. Can you determine? All right. So is there enough information given to you in this figure to determine whether they are similar? All right. If you say yes, tell me why. If you say no, tell me why not. Okay. They share R. Yes. Very good. PQ and ST are parallel, which also creates congruent angles. And also the 90 degrees, right? If I know R is going to be the same, and I know that Q and S are 90, P and T have to be the same also. All right, so there's a couple different reasons that would work. Okay, all right, next problem. Yep, last one. You plan to cross a river, okay? So you want to get across it. You want to know how far it is to the other side. Can I swim? Do I need to take a canoe? Not really sure, okay? So you want to know how far it is. So you take your measurements on your side of the river. All right, so that's going to be triangle ABC. All right, and you make the drawing shown. Here's the part of the information that they're not telling you that we need to know. These triangles are similar, okay? So I know for sure they're similar. So I can use their similarity ratios. You guys remember a ratio? Okay, so let's take triangle ABC. Okay, so triangle, I want you to write this down. ABC is similar. Okay, so the similarity sign, I believe, is just a squiggly. Doesn't have the equal sign because that would be congruent. It's similar to triangle DEF. All right, the sequence is going to be important. We'll talk about that in a second. All right, so on triangle ABC, I'm going to put 60 over 50. 60 over 50. You guys with me so far? I just took that triangle and I know two dimensions, 60 over 50. All right, what side is 60? AB. Does everybody see that side AB is 60? Does everybody see that AB is the first two letters in the sequence? Okay, so to match it up, because remember, with a proportion, the same dimension has to be matched up on both sides. DE matches with AB. So what is the dimension of DE? No, DE. Look, I just circled it. It's X. DE is X. So that's how you know it matches up on the top side of the fraction. All right, and now look. For BC was 50. That's the second and third letter. So what side matches with that one? All right. Oh, why did I put oh my gosh, why did I put an F? Okay, sorry, it's DEC. All right. Well, it makes more sense for it to be an F, not a C. All right, so for side EC, what is that dimension? 40. Okay, all right. Now we're good. Everybody clear now? Now we do our cross products. 50 times X and 60 times 40. And I get 50X equals 2,400. Okay, now how do I solve for X? Divide by 50. Okay, and X equals, what is my distance across the river? 48 feet. Okay, I could probably swim 48 feet. I would at least hope so. It's not too far. Okay, so I might swim it.
Unless there's alligators.
Yeah, unless there's alligators, I might swim faster.
I would never.
All right, guys, that's everything for today's lesson.